Hello and good evening to our lecturer, BNJ 20903, Solid Mechanics, Dr. Noraini binti Marsi. I'm Aldrusri from 1BNM. Today, I'm going to present our project Straw Load Bearing Tower. We call our project the Great Straw Tower. Solid mechanics is the study of the deformation and motion of solid materials under the action of forces. It is one of the fundamental applied engineering science in the sense that is used to describe, explain, and predict many of the physical phenomena around us. The theory of solid mechanics starts with the rigid body, an ideal material in which the distance between any particles remains fixed, a good approximation in some applications. In this semester, we will able to learn few chapters such as stress, strain, shear, bending, stress transformation, strength transformation, and column. For our project, we are divided by our lecturer into few groups of 4 members. We were instructed to design and build a tower using straws. The size of the tower must be in range of 25 centimeters in length, 25 centimeters in width, and 30 centimeters in height. The model of the towers must not more than 0.7 kilogram. Our tower is 30 centimeters in height and the width is 22 cm. The research of our our objective to construct straw load bearing tower in the range of 25 centimeters in length, 25 centimeters in width, and 30 centimeters in height. Understand how a tower structure reacts under loading. Next, demonstrate a convincing understanding on how tower construction works. Besides, develop teamwork skills as they together design and construct a tower. Problem solving along the way. Lastly, create an understanding of the tower structure and its relevant structural components. Chapter 2, there are few concepts that we are using for construct this straw loading bearing tower. First, triangular and square base for tower. The theory is use of stability and strength. Triangular and square are the two types of bases we can construct the tower. The square base can give higher stability and more vertical columns to support the tower, but will increase the mass of the tower due to usage of many straws. It can easily deform when force is exerted to the design. For this literature review, it is found that from resources that can be relatable about this project is the best way to build a tall tower is to use both triangular and square. That way we can build big structure that are less wobbly. A straw put across a square turns a square into two triangles and makes it rigid. Next, load-bearing structure. Load-bearing structure is probably the oldest and commonest type of structure, and it is the structure in which the loads of the roof, as well as lateral loads, such as earthquake, wind, etc., are borne by walls, and through walls they are transferred to the lower floor and eventually to the foundations. It is also known as wall-bearing structure. Besides, a frame structure is a structure having the combination of structural components. Example, beam, column, and slab connected together to resist the gravity and different lateral loads. Next, a truss is an important structure type in engineering. A truss is a triangulated system of members that are structured and connected in a way such that they only incur exile force. These members are considered two force members as the forces are only applied at either end of the member, resulting in either a compression or tension force. They are commonly used as bridge designs, given their ability to efficiently span long distances. When it is properly designed, trusses are efficient way to span long distances, whilst minimizing the amount of material used because the internal loads of the members are induced axially in the direction of the member in the form of compression or tension. This means less material can be used and the system more efficient as the force is distributed among a number of members. Listen.
Good evening, everyone. My name is Jason Gallo William from 1BNM. Today, I'm going to talk about Chapter 3 methodology. Basically, I will talk about the development of each stage of the design. There are two stages. So the first stage is drafting, or also known as sketching. So we draw our design on a piece of paper to get a clear idea, and all the dimensions, the angles, the shape are drawn on a piece of paper. And then after that, we move to the second stage, which is finalizing the design in AutoCAD. So as you all know, AutoCAD is an engineering software design that is widely used in engineering field because it is convenient. Okay, the feature that we use in AutoCAD is line, by drawing lines in 3D mode, and we sketch the lines according to the design that we have drawn on a piece of paper. And then after sketching the lines, we use the feature in AutoCAD that is called sweep. Sweep is a feature that makes the lines that you have drawn, makes it look more 3D. And then after that, we change the material. After using the sweep feature, we change it to plastic material because plastic looks more realistic. And then finally I want to talk about the fabrication process of our tower. So first, the straws are cut to our desired dimension, and first we made two hexagonal frames to form a solid hexagon, which is the upper part. We made the first upper part that stands a height of 12 centimeters, and then all the straws are attached by using hot glue gun. And then after that, we add truss. We add truss on the tower so that it can withstand load. And then for the upper part of the hexagon, the length of each sides of the hexagon is 8 centimeters. Okay, moving on to the second part. The second part of the hexagon, which is the bottom part. The bottom part is slightly bigger. Uh, it has 10 centimeter in length for each sides, and then as it goes up, it decreases in length for the sides of the hexagon. So it kind of look like this from the bottom. It looks like this. This is the bottom part, and then on the upper part it looks like this. It's 90 degree on the upper part, and then on the bottom it's like this. There's a angle about 60 degrees going up, and then after that we add truss to the bottom part of the hexagon. As you all know, it's for the rigidity of the structure, and also the reason why we make a bigger hexagon below, it's for the stability of the structure, so that it won't topple over easily. So I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Faris Hakimi bin Abdul Aziz. I will explain about the result from our model tower. We do some load testing to know what is maximum load that our tower can hold before failure. We use a book as a load. Then we set up a value load from 1 kg, 2 kg, 4 kg, and 5 kg. Based on the test result that we do, the tower can hold up to 4 kg. When we add a load, the tower almost breaks, and we consider it as a failure. This shows that 5 kg is the maximum load that our product can hold.
Assalamualaikum warahmatullahi wabarakatuh. Today I will explain about the calculations. Okay, first, the normal stress. P over A, which is P is force applied on the straw and A is area of the straw. So the force we apply at the straw is 5 kg, then 5 is times 9.81, so we get 49.05 Newton. And for the area, we use this formula because our model use a hexagon area. So this is the area of for the hexagons. So the answer is 166.28. Alright, then the stress is the force applied on the straw and divide by area of the straw. So the answer is 0.295 kilopascal. Second, to find the strain. To find the strain, this is the formula, and for this is a normal stress when the load is 5 kg and divide by Young modulus. So for the Young modulus, as we use is polypropylene of 1.5 gigapascal. So this value we take from the stress formula, and this is polypropylene Young modulus. So we insert to the formula, then we get 1.967 exponent -7. So then for the third, the thin cylinder. When we put 5 kg load on the tower, the top of the tower is experienced as compressive force from the load itself. From our project, we assume that 5 kg are distributed to 7 of the straw. So each straw will experience 0.714 kg from the load. That means is 5 kg is divided by 7. So each of the straw is carry 0.714 kg. Straw has a thickness of 0.1 then we are able to calculate the stress and the cylinder of each axis, which are hoop stress and longitude stress. Alright, for the hoop stress, this is the formula, and P is force that applied on the straw, R is the radius in the straw, and thickness T is thickness on the straw. Okay, for the inner radius for the straw, we have counted as 0.035, and the thickness of the straw is 0.05. So we insert this all data to the formula, so we get 24.5 pascal. Then for the longitudinal stress, this is the formula. Then we just insert all this to the formula, then we get 12.25 pascal. That's all. Thank you.
Hi, Assalamualaikum dan salam sejahtera. Okay, I will continue the presentation with conclusion and recommendation. Okay, in conclusion, our team select this design because it has several joint which tension and compress are used. Okay, next we can apply what we learn in class into this project. Okay, third, this project can help student to make some experience and give some advice to student how to build tower with perfectly. Recommendation. We have a few recommended for this project. Okay, first, student have to improve their knowledge about the tower when apply the load, and then how to determine with logical and calculation on the tower. Okay, next, student improve the stability of the tower by increasing the base area because the tower was weak to support heavy load. Also, the thickness of straw used should be increased to ensure the rigidity of the tower. Okay, that's all from our group, and thank you.